us. If you saw us yesterday, we had a presentation that was kind of an overview of PS0, and PS0 stands for Pore Strip Zero. So just so everybody knows what we came up with that. But today's presentation is going to be more on install and showing a lot of pictures and videos of our installation process and how that works, and really the benefits to all parties involved. And if you're interested, tomorrow on Tuesday, we will be presenting at 10:30 on more of an engineering side of things on restraint, and focusing a little bit more on our article that was written last June by ACI and the CI magazine on productivity around pore strips. So with that said, I am going to start my presentation here a little bit. Again, today is a little more on just the install and how it's showing a lot of pictures and whatnot. So just right off the bat, PS0 is a mechanical reinforcing splice system. So we are splicing rebar. On one end, on the left-hand side here, we use a threaded rebar that goes in our system. And we then on the other side, we have a grouted system that comes in with this loose bar. But we are a type 1 and type 2 rebar splice. So type 1 is a little bit engineering here, is 125% of Fy, which is the yield strength of the rebar. And then type 2 is the full Fu, the ultimate strength of the rebar. So we develop, just like a normal pore strip, all of your steel going through the strip itself, but now you don't have a big leave out, you just have a little joint. ICC approved and made in the USA. So we do have different applications though. I'm going to show these. So we have an application with no stressing strip, and I'm going to show a little video in a second on that application where you have one slab pour and then another slab pour back to back. So but if you need a stressing strip, we can allow for that as well, where you have one pour, the second pour, and then you still allow for stressing in a strip, but then you fill that in right away. And then a wall situation with and without a stressing strip, and then construction sequencing when you have a high rise kind of going next to a low rise building. So the first situation we really have is we have a pour on the right, the blue, and then we have a pour on the left, and the joint is here that we filled in, and our continuation rebar gets inserted before that second pour. And this detail shows a mid-span location because our moment demand is high, and we have our rebar at the bottom. So below here, we are at a fifth point or quarter point. People use different terminologies for that, but it's an inflection point where there is not really virtually no moment demand, and we put our couplers at the mid-span, mid depth, sorry, of the slab. So if you need a stressing strip, we can allow for that. So same thing here. This is a mid-span location. The rebar's at the bottom. The first pour happens on the right. The second pour happens on the left. Everything is stressed. And then the stressing strip gets poured back immediately, and then everything can be removed, nothing left in place, and just reshore as typical. And right here in this detail just shows that inflection point location. So if you have a wall situation with or without a stressing strip, we have a wall detail, and this coupler we can slot. So we have a transverse or a slotted coupler. So we allow for longitudinal movement like we typically do. And then we also allow for transverse movement across the wall. So this situation can go in with and without a stressing strip. And typically our couplers are placed mid-depth of the slab in this case, because we're not transferring any moment and tension, moment demand into the wall. So this is more of like just a pin connection, holding everything together with the rebar. So construction sequencing, we have a first pour on the right, say it's a taller building, 10, 20, 30, 40 stories. And then we have a second sequence that is coming later, and you just want to hook these buildings together. So we have a same situation. This will be a shear situation again, kind of like an inflection point. The couplers are at mid-depth, but here we have to allow for both longitudinal and transverse movement across the coupler. So our video, we're going to show this little video. And let's see if I can do the screen share, escape. Bear with me a second. I'm trying to get to this. All right. I'm going to show a number of videos.
Introducing PS0, the pore strip alternative. PS0 is a unique, grouted rebar coupler that allows for concrete volume change while maintaining structural continuity. PS0 was developed by Gordon Rigstead, president of Rigstead Engineers, a 40-year-old structural engineering company specializing in concrete construction and repair. PS0 reduces traditional 4 to 8 foot wide pore strips to a grouted joint. It saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0 mechanically couples rebar while allowing for movement caused by shrinkage and post-tensioning compression forces in the slab. Traditional pore strips require leave-out spaces and significant formwork. No leave-outs are needed with PS0. Let's take a look at the installation process. It starts with torquing a threaded rebar into the coupler. Next, a form placer is installed to the bulkhead and the coupler is placed onto the form placer and fastened to the bulkhead. Grout tubes are installed into the top of the coupler. These tubes create ports for grouting. Concrete is poured and the grout tubes are cut off. Caps are installed so no debris gets into the coupler before grouting. Before the second pour, a bond breaker is sprayed onto the first pour. Then the continuation rebar is inserted into the coupler. The adjacent slab is poured directly up to the first pour. During the specified amount of time, the joint opens up as the concrete shrinks, without the need for traditional pore strip formwork. The couplers and joint are grouted, creating structural rebar continuity without significant reforming of the pore strip. PS0 saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0, the pore strip alternative, developed by structural engineers.
All right. Thank you. That was a video of our installation process and the whole situation where we have slab to slab, that first one where there's no stressing strip needed. We are going to go through the whole process now and show some pictures. So this here is showing the torquing that happens. So people just set up a little jig and a little pipe wrench, and they just torque the rebar with we provide a torque wrench for the job. So every job gets their own torque wrench. And this is another situation here where they're torquing it. They set up a little jig here with using like an electrical conduit situation. So I'm going to show a little video of the torquing right here. How easy this is. Torque wrench just clicks, and that's it. Easy peasy, just like that. So going on to the first pour installation. So on the left-hand side, you'll see that we have a stressing strip here. This is 2 bulkheads. So on the left of that picture, we have our couplers. These are installed at the bottom of the slab. It's going to be a mid-span condition like this. We'll show a little video of this later on. And then this will all get stressed in the stressing strip. The second pour will happen, and then the stressing strip filled in. On the right-hand picture, this is just a mid-depth situation. And these are parking garages in the Midwest. So we use a lot of epoxy rebar here, especially for federal jobs too. So, so we do have epoxy coupler. Oop, going back a little ahead of myself there. Another first pour installation. This is a reinforced hospital project, and we couple both the slab rebar and we couple the beam rebar. You can see through the bulkhead in the right-hand picture that we have the slab is up a little bit in the picture, and then the beam rebar is right here with these longer grout tubes. So pretty neat. This is some formwork And it just shows that the formwork is no different. Okay, in this picture on the left, I just took this on a job site. And if this was a traditional pour strip looking down the mid span here, you would have all this extra plywood, its own special formwork that would have to be left in place until the leave out was filled in. We don't have any of that. So the formwork contractors, sometimes the same as concrete, they just get to cycle their formwork. Super easy. On the right-hand side, this is a hospital project that I mentioned earlier, and they used a traditional leave out on the floors below. So that's why you see that gap down below. But above that, it's just our pour strip above. So the formwork is just super simple and just the same as every bay. So I'm gonna do another video here.
Hello, Jared Rickstead here, Vice President PS0, checking out a first pour installation of our couplers with a stressing strip. So our couplers are installed right into the bulkhead very easily. And in this case, we have our epoxy coated couplers because this is a parking garage situation. A lot of engineers will specify epoxy for corrosion resistance. So we have the threaded bar that goes into the coupler, and the coupler is fastened right to the bulkhead, okay? And here we have them along the bulkhead, and as you see, they've already started forming up the adjacent bulkhead with the leave out in the middle here. So the first pour will happen with our couplers in it right here, as you see. The second pour will happen over here into this bulkhead, and then they can stress cables, the PT from both sides in this leave out, but the leave out can be filled in immediately and only reshored, no back shoring, only reshoring, simple system, not having to leave out. This is gonna reduce the schedule, improve the safety, and absolutely reduce the cost of this project.
Let's see here. Thank you for that. So just getting back to my slides. So second pour installation, we have on the left-hand side, this is our continuation bar going into that slab. And on the right, we have just a close-up of that. The coupler's in there and the continuation bar just slips right in. Super easy. Another second pour installation. Here we have couplers top and bottom. So sometimes the moment demand, this is a mid-span condition. So the moment demand is high at the bottom. So we have these couplers spaced about 16 on center. And then if the engineer wants some top couplers, and this is a thicker slab, so we can add those as well pretty easily. And those are spaced out at like 2 or 3 feet on center here, because there's really theoretically no tension demand here, unless it's really diaphragm action. But in this case, it's only, they have enough with the bottom rebar. So on the right-hand side, you see this stressing strip that's in play there. And I'm gonna show a little video of this in a second. So where you do have this stressing strip, the second pour is happening and that will be just filled in, and our continuation rebar will lap with the rebar coming from the other side. So this is just the concrete being poured, super easy. They're pouring the concrete, the joints on the left-hand side, the joint is right here, that's your pour strip, and our couplers will be grouted later. They're showing up right there. And here on the right-hand side, this is your new pour strip. This is it. You don't need this big leave out, and you just, there's really no reason to have this leave out anymore when you have a system like PS0. So I'm going to show a pour 2 install video, and this was just fairly recent as well.
Jared Rickstead, Vice President of PS0 here, checking out a stressing strip situation, as you can see behind me, at a mid-span pour strip location on a project. It's a 12-inch slab. We have couplers on the bottom spaced at 16 on center for the high moment demand. A lot of times we don't put couplers at the top because there's not really a need for them. But when the slab gets a little thicker, it's nice to have those, and they're spaced out further, like 3 foot on center here. So the second pour is happening, and we need this stressing strip because, as you can see, we're surrounded by walls. We're in a basement condition with sheet pile walls. So they weren't able to get at this at the second slab edge to stress. So this is the bulkhead here of the second pour. They will finish pouring this, stress the cables, cut the tails, and they will put our continuation rebar into our couplers down here, and that will lap with this rebar in the stressing strip to create the continuity and allow for the movement of this gap, but without the big leave out that would have to be left in place normally on a typical pour strip. And they can immediately pull the formwork and just reshore as you typically would, which is saving a bunch of time and effort and ultimately money and schedule on this project. Thank you.
All right. I'm going to show one more video that we have for a wall condition. So we have our couplers that are slotted, are installed in a wall.
Jared Rickstead here with PS0, Vice President, checking out a installation of our couplers, our slotted couplers in a wall condition, stair tower. And in this condition, we need to allow for stress to be relieved in two directions, both along the coupler and transverse, side to side to the coupler. That's why this hole is slotted. And as you see here, we have our couplers with the threaded bar installed, and on one side of the wall with the PT going in, and these are epoxy. This is in a parking garage, and so a lot of times epoxy rebar will be specified in parking, so we can do that. And we have the other side of the shear wall, so it's a double shear wall here. So this system being placed here is going to relieve all the stress, so you won't have cracking. It's going to improve the safety because you're not going to have to come back and worry about any leave outs, and it will accelerate the schedule and reduce the costs on the project.
So let's see, getting back to, so I think those videos, tell their story here more than these pictures can, but here's what these joints look like. On the left, you see from above, right here, look at all this lay down room, okay? This is no more, you don't have a leave out anymore, and you're allowing for the gap. In the middle, we have a joint from below, so this hasn't been grouted yet. So there's some water leaking through, but this will get grouted and seal up just like a normal pour strip, just without the gap. And now we're measuring, engineers are able to measure these gaps, which have a lot to do with stiffness and when things are stressed, if it's PT, things like that. So you can't really totally tell all the time how much things are going to open up. But here's the grouting process. So instead of having a big crew come back and pump trucks and things like that and wasting concrete, because that's the most expensive concrete that they pour on a job, we just have a small crew of a couple people, just hand mixing. We supply a slump measuring tool, and typically they're just doing a gravity feed. We've tried grout pump guns. They work okay. So it's just really contractor's choice when it comes to this. So it's just a couple guys and or gals, and they're just doing this, and it's taking very little time. And you see on the right-hand side, this is a podium project we did. All this wood framing is up. So this wood framing over this strip right here would not have been able to have even started if it, until that old strip, this strip would have been poured in, the old traditional pour strip. And these pictures tell a great deal of what's really the savings are, because it's not just the savings in formwork. It's not just the savings in the concrete. Everything trickles down to the other subs finishing a job. So you can see all the mechanical, the duct work in here, the plumbing. You see the wall system going in the middle picture there. All this would have to be delayed and they'd have to come back. So we're speeding up the productivity on job sites with the use of our system. And here's some more pictures from above. You see the joint grouted. Simple solution. Again, this is the podium part on the right, these right-hand pictures. Again, this wood frame went up. I think the leave out was 45 or 60 days on this job. So they would have had to delay all the wood framers through here for that long of time. So we're going to get into a couple projects here. And this was a hotel we did down in Rochester, Minnesota. 3 levels of PT with 4 levels of wood on top. 2 pour strips, as you can see on the left, and we provide shop drawings, showing those on the right-hand side, placement drawings. And this is the system going in. Pour 1 on the left, we got pour 2 on the right, the continuation bars. So our couplers are just easily fastened to the bulkhead, and the continuation bar goes in, the bond breaker gets put on, and the second pour happens. So, and these are some of the pictures we kind of just show. I show them as part of that, because it's such a good picture. This is a really tight site in Rochester near the Mayo Clinic. So they needed all this laydown room. And again, having all this ductwork and plumbing be installed right away, it's priceless, really. 1, 2, 3 levels of wood are up before they're even grouting this podium. So lots of podium structures going on around the country, a lot in California, Texas, which I mean, across the board. Minnesota, where we are, they're everywhere right now because, people think that putting this wood structure has become economical on top of PT and concrete. So this allows, and cold form as well. So we're working with cold form suppliers too, because they have to leave their stuff out when that pour strip isn't poured back. This is a hospital project, a one-way reinforced concrete joist system. They were 2 months behind schedule, and they found our system on the 4th level of 6. So we came in for 4, 5, and 6 with our system, and they're telling us that they're opening on time, and they made 2 months back by using our system. So a 5th point location, inflection point, shop drawings on the right. That's the location of the pour strip on the left. This is what things look like. So we're doing beam rebar. We have number 6s, number 7s, number 8s. So we can do beams, we can do PT, we can do unreinforced, reinforced concrete and PT. So doesn't matter, pour strips are everywhere. So on the left-hand side, you see the beam steel coming out. We're going to couple that rebar, which you see in the middle. And then on the right, you see the continuation bar going in to the slab, and that'll get poured back. And this will be the joint that opens up on the far right. So here they are, finishing off the slab. This is the new pour strip. So our couplers, you can see the tops of our couplers, and they'll get grouted later at the specified time. And actually, contractors aren't pushing engineers as much with our system. So especially on a higher end project, or where you really want to control cracking, like a parking garage, you really just have to, they can go even 60 days, 90, just really, it's not on the critical path anymore. So engineers, for better performance, are leaving them open longer, as long as it's not a schedule issue. So here's that same project. So on the left-hand side, you see looking into the formwork, this is the traditional pour strip below, and they had to back shore this because this reinforced concrete, this slab can't be self-supported. And then above, you see the top arrow, that's our new joint. See, they can just cycle all their formwork, no special formwork at all in the system. Makes things super easy. That's where formwork contractors make their money, cycling the same formwork over and over. On the right-hand side is a picture looking out. The old pour strip below, our new strip above. The formwork's all the same from bay to bay. And this is beautiful right here. It shows a bird's eye view of the system in action. They're already flying all these tables in, and they're no different than the adjacent bays over the pour strip. And this is our pour strip right here, our new one. That's the old one down below. You can see why we saved them the 2 months in schedule, because they were able to cycle all this formwork and get all of their other trades in. It wasn't just in our system, but our system created an opportunity so everybody could work across the joint that was closed. They just have to grout it later. So all of the MEP, everybody, the finishers, everybody that came after the concrete finished their work sooner. This is a parking garage here, where actually, those of you who have used or seen the lockable dowel out there, we were actually less expensive because the engineer, Kimberly Horn, they specified the lockable dowel on this project. It was a parking garage, and it was at a 5th point location. So you can see these joints, a 5th point, because the lockable dowel really is restrictive, needs to be at a 5th point because it really is just a shear dowel. It doesn't transfer high tension loads at all. It can't. It's just a smooth dowel, and it's not very long. It only embeds into the concrete like 9 inches each side. So it's kind of like having an expansion bolt with non-ductile failure. So when we came in, we're able to go 1 for 1 and be less expensive on this job. So there's their detail on the left, and their detail also requires all this additional steel, a lot of U-bars and a lot of longitudinal number 4s as well. So we don't need any of that steel because our rebar is just continuing with the rest of the rebar that's in the slab already, just like you normally do in all of your reinforced and concrete design calculations. You can see the dowel right here on the bottom left. That's the dowel, not very long. That doesn't transfer high tension loads. So this is a cantilever column lateral system. So if the lockable dowel is going to work in anything, it might work in this solution because all those columns are acting as part of the lateral system and they don't have to transfer diaphragm loads across the joint. So here they are, just torquing our system like we showed this earlier, install on the right. And here they decided, because it was a federal project and they had already bought all this additional rebar that the lockable dowel needed, they just left it in place. They didn't want to remove it. But now you can really see all these U-bars that are adjacent to our couplers. These are U-bars, and these longitudinal bars that go along transverse to our couplers are all needed because of the lockable dowel, and they're needed because of ACI chapter 17. Those of us from years ago remember appendix D for the shear values, not for anything else. And you can see all this steel that they need right here too. Look at the labor involved in putting all that in. It's just tremendous. But they wanted to leave it in as their prerogative, and they just substituted our system for the lockable dowel. Pretty simple solution here. You know, just hand finishing around our grout tubes. And this is the finished product. You know, we have the joint and opening up. Pretty simple, easy stuff. So the benefits to the former contractor: there's no back shoring with our system at all, only reshoring. Okay, all the forms can be removed and flown here if you fly your forms like, you know, this job was. No special formwork at the joint, nothing left in place. And if you're doing our slab to slab application, you only have one bulkhead. If you have a stressing strip, you will still have two bulkheads. But if it's just slab to slab and you get at the outside edges of your slabs, then you just have one bulkhead. And you're going to finish your work sooner. Okay, concrete contractor. Okay, only large slab pours, okay? No small strips anymore, no pumps back, only a couple people back to grout the joints. And usually it's a 2 or 3 person crew. And that's it. It's only one joint. There's not two, because in a typical pour strip, you still have 2 joints, and concrete contractors hate maintaining joints. They know that's the worst thing to get called back on. Again, if you do the slab to slab connection, you only have 1 joint. And you can have a higher quality structural slab, because if the engineer is allowed to leave and not grout our couplers, essentially leaving the strip open longer, you're going to have less cracking, because more volume change happens the longer you leave it open or the longer you wait to grout our couplers. And you're going to finish the job sooner. Okay, general contractor, you and the owner actually have the biggest benefits here, because your schedule is going to be accelerated tremendously. Okay, your concrete work will be done sooner. And you know, when your concrete contractor is off the job, it's go time. Get the finishers in, get all the other mechanical trades, electrical, plumbing, everybody, your wall systems in, okay? And you can have a higher quality slab to turn over to your owner. Like I said, if you let the engineer leave, if it's no longer, the pour strip is no longer on the critical path, you can leave our couplers ungrouted longer and get better performance. You'll reduce cost and the safety. What's the number one thing on a job site? Safety. General contractors concerned about safety, okay? So we don't have the leave out, you don't have to bridge across. People can work floor to floor right across the joint. It's super easy. And you know, that's going to improve your productivity, not even your productivity with just the pour strip and the concrete, but getting your other trades just to, like, you know, walk across a joint instead of bridging across an open strip like you normally have to do with the pour strip. It's really a no-brainer, and that's what all of our repeat customers are telling us, okay? And they're really telling us, you know, that it's not really a cost issue when you look at everything. And our system is on par with what a typical pour strip costs. What a typical pour strip costs the general contractor. When we talk to contractors and concrete formwork people, we say, hey, what is the actual cost of this? Because they haven't broken it out, but once they break out that cost, which we think is somewhere, which we've been told, between $100 and $200 a lineal foot, our system is between $100 and $200 a lineal foot. So it offset by all those other savings. So just wanted to thank you for hanging out with me today for this meeting and in this little presentation. Wish we could have been doing it face to face. if you're more interested, you can tune in tomorrow at 10:30 Eastern. We'll be doing another demo. It's going to be focused a little more on the engineering and why you need pore strips and the volume change issues and the restraint issues. We're kind of running a little bit tight on time here, but there was a chat. No, 5 minutes to us. That's just Kim. Thank you telling me about the time. So I think we're right at a half an hour. So if there's any questions, just please reach out directly. Come to our presentation tomorrow. We're running around the country, giving lots of lunch and learns. We're doing tons of jobs around the country too. So we're probably in town doing something. We can easily stop by and do a little demo and drop off a sample. So thank you so much. Again, Jared Rickstead, PS0. Appreciate your time.